I'd like to talk a little about language models and facts, which is to say the relationship between the text that language models produce and the truth. I want to start by reminding everyone that these models go through a training process during which they learn how to look at text and predict the next word. This encoding turns into fluency. The result is that they are very good at knowing how to say things and say them well. So we get, as the orchestra embarked on a symphonic journey, each note danced with precision and grace, crafting an auditory tapestry that transcended the confines of time and space, inviting the audience into a realm of unparalleled beauty. They're fluent, and they can predict words that sound just right. But what about this? George Clooney was born on May 6, 1961. Pretty much any language model will be able to produce this. But that's not just pretty language. It feels like a fact. They seem to have an awful lot of facts at their disposal. But if all they're doing is predicting words, how is it that they seem to know so much? Well, the reality is they don't know any facts at all. They don't have any sense of what is true or what is false. They do have a sense, however, of what the most likely next word is. They're not producing words because they express the truth. They're producing text based upon the words that are the most likely given the current context. As it turns out, it's often the case that the most likely next word doesn't just sound good, it's true. And this holds at scale. If we ask for a bio of George Clooney, we get George Clooney is an American actor, producer, and filmmaker, born on May 6, 1961 in Lexington, Kentucky. He gained widespread recognition for his role as Dr. Doug Ross on the medical drama ER, which aired from 1994 to 1999, and so on. Each word picked because it was the most likely next one. But understand, the statement produced is true only insofar as it is likely. It's not knowledge of George Clooney that drives the generation. The words are a product of calculating the likelihood of the words associated with the words in his name, the word bio, and then words that the model itself is writing. The correlation between words that are likely and those that express the truth is high, but it's by no means certain. The odds that any statement generated by a model is true is determined by how often the system has seen variants of it in its training and how indicative the words are themselves. George Clooney as a phrase determines a lot. Tied to born on, the odds of May 6, 1961 showing up are pretty good. Facts that are stable in our text and expressed by strong identifiers are going to skew the likelihood of the words that are predicted towards also being words that are true. We just don't see a lot of examples of documents that get George Clooney's birthday wrong, and George Clooney is a strong determiner of the words associated with him. But facts that change over time or are not expressed all that often in text don't share the same weight. My birthday, for example, although it is online, isn't out there enough to determine the right predictions. It doesn't change, but it isn't repeated. Likewise, the answer to the question, who is the mayor of Chicago, is pretty much unanswerable by language models. It changes over time, and to get it right requires knowing more than what sounds right. Likewise, facts that need to be calculated cannot be generated directly by these models. If I ask how old George Clooney is, any system that tries to answer it needs to calculate the answer using the current date and his birthday. For all these examples, we need mechanisms that determine what to say, that is the facts, before the models do their impressive job of knowing how to say it. The more sophisticated models can use public resources to look up information and use the text they find to define the truth. Wikipedia can tell them who the mayor of Chicago is, so the language model can articulate it. Likewise, they can call on other programs to perform calculations for them. If we ask GPT-4 about George Clooney's age, we get an answer because the model is calling on a completely different system to look up today's date and do the math for it. It's important to understand in both these cases, the language model is using external systems to determine the facts. There are things that LLMs cannot do, so we pull other systems into play to do it for them. These systems do search, look up facts, or perform calculations that the language models cannot. The important part is that they have to do so because the language models not only do not have all the facts, they don't have a way to hold on to facts to begin with. The facts that the LLMs are going to get right are things that never change. Mount Rushmore isn't going to get up and move. It's always been and always will be in South Dakota. So all the texts associated with it that the system has been trained on never mention any other location. LLMs say Mount Rushmore is in South Dakota, not because it's true. They say it because the most likely word after the phrase Mount Rushmore is in is South Dakota. But the world of facts that change over time and those that need to be calculated is huge. In fact, most of our adult communication is focused on the things that change rather than those that stay the same. The question, how many students are in computer science at Northwestern, is hard for a language model to get right. The model has no place for it, and the number changes. But other systems can answer the question, and they can then be used to guide the generation of facts by LLMs. LLM systems are good at knowing how to say things. They're just not good at knowing what to say. So unless you're checking all the model's output, you should probably avoid using them as sources of truth. Unless the truth you care about is so commonly discussed in print that it's also likely, because that's the only truth that language models know. Thanks for listening. And please, please, stay safe.